I actually have one more you try video that I didn't mention in the last one. So give this one a shot as well. Same type of problem. Use the graphing calculator if need be, and then find all parts A, B, C, and D. And here are my answers to all this stuff. So check it out. Hopefully it went okay for you. We're going to turn the dial a little bit more, and we're going to graph functions with e in them and the natural log of x. So these are kind of containing all kinds of irrational numbers. So here we're not looking for precision as far as nice, neat coordinates, but we're kind of looking for general shape. And there usually is like one important point or kind of an anchor point for these functions. So here I've got some function, and this is a little bit different notation, but it really is the same as f of x. So this is the function called f where x maps to e to the x minus 3. So that's all that means. And then I want to do kind of similar stuff that I was doing last time. I want to find the inverse equation. I want to sketch the functions f and f inverse. And then I want to state domain and range, find asymptotes, and that's basically it. So we're going to need some calculator help for this guy. But first, let's find the equation defining the inverse. So we can do that, and if I kind of think of this as y or x equals e to the y minus 3, that's kind of where I'd start off, and I'd solve for y. I've got this e, or this exponential by itself, it's isolated, so I'm ready to convert to logs, and I'm going to use the natural log since that has a base of e. So the natural log of y minus 3 equals x. And, oh, no, I have that opposite. Excuse me. This is the natural log of x equals y minus 3, since this equals the exponent. Right. I think I got it that time. I'll add 3 to both sides, and this becomes y equals the natural log of x plus 3, or f inverse of x equals the natural log of x plus 3. So we're going to kind of keep that in mind. That is my inverse exponential, which is a log. Okay, so now we want letter B. We want to sketch these graphs on the same set of axes. And once again, hopefully I gave you a graph here. I thought I did, but I seem to have forgotten it on my notes. So I'm going to kind of do a rough sketch here, and you can kind of follow along with me. Now I'm going to just jot down what I had from the last example for my answer here. I'm going to kind of copy this and put it in here so I can keep track of my inverse. I'm going to get rid of this. So here's my inverse, and I want to sketch the inverse and the original function. So let's use the graphing calculator here. I'm going to plot my function e to the x minus 3, so that's going to be second ln e to the x minus 3. And then my inverse will be the natural log, let me clear that, the natural log of x plus 3. And I can take a look at what this graph looks like, something like this. You can kind of see that they reflect over the line y equals x, so that, it's all good. Now, as far as some nice, neat points for this, this is where I might go to the table, and hopefully I'll find something that looks kind of like an ordinary point. And what I'm seeing right here is I'm seeing 3, 1, and I'm seeing 1, 3. And that's kind of going to be like my anchor point. And if you can think about what we talked about in a couple of videos ago, we said that all exponentials of the form a to the x, they all have a y-intercept of 0, 1. And really, this is no different. The only difference here is that I've got a minus 3. So that means that I've taken my y-intercept and I've just moved it to the right 3 units. So that's why if we look at our table, rather than have the point 0, 1, I have 3, 1 in my exponential here. So I really this is the only coordinate that I want to make sure stays on this graph, this 3, 1. So let's graph that. Let's do my f of x in blue. Here's blue. And I want the coordinate 1, 2, 3, 1. I consider this kind of be like an anchor point, we might call it. So this is 3, 1, and my graph is going to look something like this. And f inverse of x is going to be my logarithmic graph, and that is the point 1, 3. So let's plot that one as well. 1, 3. And we can look back and forth between our graph just to make sure we have this right. and it's coming up with that asymptote of x equals 0, and it's kind of veering off towards infinity. So it looks something like this. And that, roughly is about what my function looks like. So this is f inverse of x, and this my blue one is f of x. And I know maybe if you're like me, it feels kind of weird to like not have more points on there and not be more like accurate. But really, we're looking for the shape of this thing, and we're looking for these anchor points. Other than that, I wouldn't expect you to plot specific points as given by this table, but I would want you to kind of have things close to it. All right, so let's keep going here. We want to state the domain and range of f and f inverse of x. And so really what we're doing is we're taking a look at the domains, which was normally for my original function. The domain is all real numbers, so negative infinity to infinity. And the range, I've not made any sort of vertical shift, so this is going to be from 0 to infinity. That one was kind of easy. And then for my, my inverse function, I'm just swapping my domain and range. So this is going to be, the domain is from 0 to infinity, and the range is from negative infinity to infinity. And since we have these things graphed in our calculator, it's always a good idea just kind of give it a little look and make sure that that seems right. So my blue function, yeah, looks like negative infinity to infinity, y values from 0 to infinity. I think I got this. All right, and then finally, D, find any asymptotes and intercepts of f and f inverse. So we're going to do the same thing we did before. The asymptotes, let's start with my function f. That asymptote is going to be a y equals 0. And for my x-intercept, I don't have any, and hopefully that makes sense, because if my y equals 0 asymptote exists, that means I'm never actually crossing or touching the x-axis. So there's no x-intercept. Let's see if we can find a y-intercept. And the way we do that is we set x equal to 0. So y is going to equal e to the 0 minus 3. That means that my y-intercept is equal to e to the negative third, or 1 over e cubed. So I can write the exact value of my y-intercept as 0, 1 over e cubed. For my, and I can kind of punch in what an idea of that value is if I wanted to. So this would be 0, let's actually type that into the calculator. So let's type in 1 divided by e to the third power. And this is what it is, 0.0498. Let's do that. 0.498. So roughly equal to this, approximately equal to this. For my inverse function, the domain, or rather the asymptote is now x equals 0. The y's become x's. And similarly, I didn't have any y or any x intercepts for this function, which means I won't have any y intercepts in my inverse function. And the actual intercepts, they switch as well. So I don't need to go through all the algebra here. I can just take this, what used to be a y-intercept, and now make that the x-intercept of my inverse function. So this now is the x-intercept in my function f inverse of x. And let's kind of verify that with the graph as well. So I'm not sure if I'm actually going to be able to get this because of where my calculator doesn't keep graphing, but let's see if I can figure that one out. So I'm going to second calc, I'm going to look for the 0 of, oh, it looks like I'm on the blue function. Can I? Okay, if I press down, I can change my functions. So my left bound would be, looks like it's not going to get it. Yeah, it jumps from an error to my positive values. So you know what I might need to do? Let's see if I can't change my window to get a little bit closer to this thing. So let's make my x-min from -1 to 1. And let's make my y values from -1 to 1 as well. We're going to get real tight in on this, what's going on around the origin here. Okay, now I can see this. So let's calculate the 0 of my red graph, my red curve. This is my inverse. So left bound, now this is looking good. There's a left of my 0, and here's to the right of my 0. And I hit enter one more time, and there's my x value again. So 0.04978, and that's what I had over here. All right, so lots of stuff with e. It's not super precise because these are irrational numbers, but as long as we can get good approximations, we're in a good shape. So why don't you try the same type of example now? 4 parts using e as my exponential. Pause the video, give this one a shot, really dig into it, and we'll see how it goes. All right, and here are all of my answers for this one. So I did graph this for you on Desmos, and I really, again, once you find what these anchor points are, those are the only ones that need to be labeled. Other than that, you need general shape. I do need to include this horizontal asymptote of x equals -2, and this, or vertical asymptote rather, and this horizontal asymptote of y equals -2. Those things are important. But other than that, hopefully you're able to kind of work through the calculator pieces to get a nice picture like this, and the domain and range hopefully flowed out of that.